Okay, we want to write this equation in exponential form, and we use these big deal rules that I put in red last time and everybody learned.
Yes.
Okay, so what's the rule say? Well, to apply the rule, is this in this form or this form?
The log.
It's in this form.
Yeah.
And, okay, it's in, so what's A?
A's A.
A's anthill,
And B would be
B is aardvark. Okay? Anthills and aardvarks love each other, right? Actually, it kind of just goes one way. But, okay. But
Not symbiotic.
log and exponential functions go two ways, unlike aardvarks and anthills. Okay. So A's anthill, B's aardvark. 2 to the B equals A. So 2 to the aardvark equals anthill. So if you don't know anthill, but you do know aardvark, then you can find anthill by raising 2 to the aardvark.
My calculator couldn't do this.
Okay? Now, you can do 2 to strange things. You can do 2 to a matrix, but you don't want to know that. Okay. Okay, so anyhow, so you could have strange things and raise 2 to the power of an aardvark, I guess, somehow. Okay? But if aardvark is a variable that stands for a number, you can certainly do it, right? Okay, well, anyhow, that's a incredibly fanciful example. But let's get back to Earth here and try log base 2 of x equals negative 0.3. Okay? What's this equivalent to? Well, A would be your x and B would be negative 0.3. So you have 2 to the negative 0.3 equals x. Right? Okay? So the calculator will give you the solution. And that would be the value of x, the log of which is negative 0.3. Number you would take the log of to get negative 0.3. Okay? You could estimate what that number is. And actually, well, no. Okay. On your picture, okay, I was not going to do this, but I am. Okay, just slop down a graph that looks like the log of x. You know 1 is here, and 1 on the y-axis would be here, so that the 0.3, negative 0.3 is here, so x is here, right? Because this would be the log of x is negative 0.3. So it looks like x is about 0.7. Well, that depends on how well I drew the curve.
It's actually 0.8, 0.81. So you're not really
So it
close.
wasn't far off. I didn't do too bad. Okay? Wasn't great. Because it's clearly not 0.8 the way I drew it.
Yeah.
Okay, anyhow, that's just a picture of this equation, isn't it? So it's very helpful if you can draw that picture. Because you know how to draw the graph of log base 2. You know how to draw the graph of 2 to the x. They're inverses. And using that inverse property, the inverse property is just all this is, incidentally. So I'll talk about that in a minute, okay? Now, you got log base 2 of x plus 4 equals 1.6. And A then would be x plus 4. B would be 1.6. So you have 2 raised to the 1.6 equals x plus 4. Now we want to solve the equation. So we first see that the x that we're trying to solve for is part of the argument of the log function, and we revert this to exponential form. Okay? But when we do, the thing we're taking the log of is not just x, it's x plus 4. So this gives us an equation for x, and the solution is clearly that x equals 2 raised to the 1.6 minus 4. We subtract 4 from both sides. Okay? Then we do this. And 2 to the 1.6 is pretty close to 3. Okay? So we're going to get about -1 maybe for x. But you got that with your calculator. Okay. So, yeah.
Nah, I was,
Okay. Yeah, you just. Okay, good. So solving logarithmic equations isn't all that bad unless they get tricky on you. Okay? And most of what you're going to see isn't tricky. When it gets tricky, you're going to have fun with it. But most of what you're going to see and most of what you're going to be tested on is fairly straightforward. Okay? Now what if I don't have it, but let's say I had log base 2 equals this. Well, you just do the same thing. You get 2 raised to 0.7 equals x squared plus 5x plus 6. Okay? Then what do you do?
Find 2.7.
I'm sorry?
Find 2.7.
Okay, what I'm going to do is I'm going to put it in the equation of a standard quadratic.
You just subtract 6 from both sides, and then you
No, you would not subtract 6 from both sides.
You subtract the 2 to the.
Yeah, want to make sure we don't think you do that. To solve a quadratic equation, this is quadratic. This is just a number, okay? You have to put it in the form
A squared plus B. So then you subtract
okay?
that
You can't,
from both sides.
if you get your x's on this side, you got an x squared and a 5x, there's nothing you can do with that, okay? Doesn't work, but if you put it in the form of a quadratic,
That's it.
well, you get x squared plus 5x plus 6 minus 2 to the 0.7 equals 0, right?
That's right.
Okay, well, what's 2 to the 0.7 power?
That's what 7
1.6.
1.6? That's what I was going to guess. So
1.6.
approximately this, so that x squared plus 5x plus 4.4 equals 0. And now we use the quadratic formula. So there's nothing particularly tricky about this, but the thing that doesn't look quite right is having 2 to the 0.7 as part of a quadratic equation, right? You have to know that this is just a number that you can approximate on your calculator. Now, if you want to get a really accurate solution, your calculator is going to give you 10 decimal places, okay? In the 2 to the 0.7. So you could use a couple more significant figures here if you want to get a more accurate solution. And I say approximate here because 2 to the 0.7 is not 1.6, it's just close to 1.6. So any solution that we get using 1.6 is going to be close, most likely close to a good solution. Okay? Now the whole idea though is, again, if you get the equation into the form of a log of something equals something, you can always change it to exponential form. And then, if you're fortunate, that's an equation you could solve, which would be the case for any of these examples.